Hello dear students. In last lecture we have seen the introduction of Turing machine. In this video we will see how to represent the Turing machines. We can describe a Turing machine by employing three things. First is instantaneous description using Moore relations. Second is transition table, and third is transition diagram, or it is also called as transition graph. Snapshots of Turing machine in action can be used to describe the Turing machine. So whenever you want to describe the Turing machine, the snapshot is used to indicate entire things about the Turing machines. These snapshots gives us the instantaneous description of a Turing machine. We can define the instantaneous description of PDA, that is push down automata, in terms of current state. The input string to be processed and topmost symbol of push down store delta Q0 AA that we have seen in the video of push down automata that we have defined already. But the input string to be processed is not sufficient defined as the ID of Turing machine. For read-write head can move to left as well. So when we want to describe the PDA, there is one drawback that the input string to be processed is not sufficient to define the ID of Turing machine as well as the direction of the head. So an ID of Turing machine is defined in terms of entire input string and the current state. Now let us see what is then ID. An ID of Turing machine M is a string alpha, beta, gamma, where beta is the present state of machine M. The entire input string is splitted as alpha, gamma. The first symbol of gamma is the current symbol A under read-write head, and gamma has all the subsequent symbols of the input string. And alpha is the substring of input string formed by all the symbols to left of A. Now let us see in more details. So a snapshot of Turing machine is shown in figure to obtain the instantaneous description. So this is the snapshot. We are at state Q3. Read-write head is pointing to A1 and all the symbols are located at different cells on the tape. So the present symbol under read-write head is A1 because read-write head is pointing to A1 cell. The present state is Q3. So A1 is written to right of Q3. The non-blank symbols to left of A1 form the string A4, A1, A2, A1, A2, A2. So this is the string to the left side of A1, which is written to the left of Q3. The sequence of non-blank symbols to the right of Q3 is A4, A2. We do not count here BB because as per the definition of Turing machine, we have already seen in the previous video that this B indicates blank symbol and this B does not belongs to any input symbols. So this is the representation of ID. We are at Q3 state. At Q3, head is pointing to A1. So at the left side of Q3, we have A4, A1, A2, A1, A2, A2, that is the left string to A1. And what is right to A1? Right to A1 is A4, A2. So we have left sequence and right sequence. This is how we can represent the ID of Turing machine. This is all about the representation of Turing machine. Thank you for listening.